Hello guys, welcome to my YT channel. This is I am a singer, eternal voice. Previously, on my live stream yesterday, I discussed about the basic concepts of macromolecules, right? There are four main classes of macromolecules. We have carbohydrates, proteins, lipids, and nucleic acids. Okay, yesterday we gave already the overview of carbohydrates, right? So this time I will be able to show to you the molecular structural formula so that we may understand the different isomers of sugars. Could it be a monosaccharides, disaccharides, and polysaccharides? Okay, let's start first with monosaccharides, which are the aldoses. Aldoses, ELDOSES, composed of trioses, pentoses, and oh. So what is the specific example of trioses? Trioses is glyceraldehyde. Okay, let's touch first glyceraldehyde molecular structure. Formulas or formula. Okay, wait. I need pen. This one. Charot. Sabi. Trioses. Okay. Trioses stands for the word tri, meaning three. So three carbon atoms, right? Trioses. So these are monosaccharides, simple sugars or carbohydrates, right? Okay. So the formula is this. I will teach you also the technique for this, okay? So specifically, glyceraldehyde. Oh my gosh! Trioses, we have three atoms of carbon, okay, six atoms of hydrogen, and three atoms of oxygen. From the word trioses, and you always put, okay, SE, right? SES at the last part of the word trioses, okay? And then, so if you speak tri, the carbon atoms are usually three. So this refers to three carbon atoms, okay? Now, the atoms of oxygen will be the same with the number of atoms of carbon, right? Three. And then, three plus three is equals to six, and that will be your atoms in the hydrogen. So that's the technique there, okay? And it goes up the number of carbon atoms, let's say 4, 5, 6 is the same technique will be used, okay, as it will go higher, right? So this time, so three atoms of carbon, so automatically three atoms of oxygen also, okay. Okay, like that. So three atoms of carbon and then three atoms of oxygen also. So 3 plus 3 is equal to 6 atoms. So that would be your number of atoms for hydrogen. That's why C3H6O3. Okay, so this is glyceraldehyde. Okay, glyceraldehyde. Okay, so the same with glycerol, but glycerol is just a sugar alcohol. It ends in OH. Okay, but the same principle behind, there are three carbon atoms. Okay, if we speak about glyceraldehyde and glycerol, so three carbon atoms. Okay, like that. But glycerol is just an alcohol. Okay, sugar alcohol. Why sugar alcohol? Because of the word glyceraldehyde also. It's being connected with alcohol. So glycerol. Okay, like that. But the key term is glyceraldehyde. Okay, or glycerin. Okay, if you speak about glyceraldehyde, so aldehyde family. Okay, glycerol alcohol family. Okay, very clear. But we are focusing now on the sugar, so glyceraldehyde. So it's very, confusing because we are talking about simple sugar, but then suddenly there's an aldehyde attachment of glyceraldehyde, right? So you will be confused why like that. So this is the exemption behind simple sugars, okay? Monomers of sugars, okay? Like that. Okay, formula or molecular structure will be so C3H6O3, you will put three carbon automatic. So that your be your basis. Okay, carbon atoms will be your basis in the molecular structure formula. Okay, three carbon one. Gosh. Okay, we cannot see this in our naked eye because this reaction is, we cannot see that this in the our eyes, but we can see this through laboratory test, okay, or experimentation. Okay, we will get a sample of food substance or biological substance, and then we test that one. Okay, this is only a theory of the molecular structure, so that we can easily understand further. Okay, like that. Three carbons. So one, two, three. Okay, like this. So double band of oxygen. Gonna. Okay, like this, like this, like this, like this. So again, this is a covalent band. Okay, with hydrogen bonding, something like that. Okay, H, H, OH, H, OH, something like this. Okay, so there's one double bond in the upper portion of the carbon atom. Okay, like this. Oh my gosh. Nakakaloka. Okay, this one. Okay. This one. Okay. This is the formula for this. So there are three carbon atoms in the vertical position, and at that portion there will be a double bond between carbon and oxygen, and the rest will be hydrogen, four single band of hydrogen attached to the carbon, and there are also two hydroxyl group OH attached in the carbon in the right side, something like this. So this is the formula. So count that one. There are one, two, three carbon. Okay, oxygen. Count that one also. One, two, three, right? And then hydrogen. One, two, three, four, five, six. So hydrogen six, both hydrogen six on the general formula. Three atoms of carbon put in the general formula, and three atoms of oxygen put in general formula. That's why we have C3H6O3. So general formula are being breaking down. So this is gonna be perfect covalent bonding. Okay, there's no excess electrons unshared. So if there's no excess, this is equal sharing of electrons. This is non-polar covalent band. Okay, because there are four electrons in the outermost shell of the carbon atom, right? So all are shared between hydrogen, oxygen, and hydroxyl group. So there's no balance, there's no unleft, there's no left unbalanced. Okay, so all are shared. Sorry. So this is non-polar covalent band. Okay, so this is triuses the glyceraldehyde. Okay, number two example of simple sugar under aldoses. Oh my God, aldoses pollution. Aldoses pa tayo ha. Okay, we have, oh my gosh, ano ba to? Number two is ribose. Okay, ribose is very important in the genetic factor or in a gene coding. Okay, gene coding of the DNA. Okay, protein DNA. Okay, like the deoxyribonucleic acid. So this is the main sugar used there. Okay, so ribose. Okay, ribose. This one ribose. Ribose is a pentoses. Okay, from the word penta in algebra, right? meaning to say pentagon, 5 sides. Okay, in a polygon. So this is also applicable in the organic chemistry or biochemistry. So let's make the pen two, not penta. Okay, only pento. I cannot explain why pento as long as there is words P-E-N-T. So pentoses. Okay, this is pentoses. My gosh, ribose pentoses. Okay. Ribose is specific sugar. Pentoses is general, having 5 carbons, so pentoses. So you will start with carbon, right? So pentoses 5 carbons, 5 atoms of carbon. So automatically the oxygen is 5 also. Okay, the technique, right? So 5 plus 5, 10. So that will be your atoms of hydrogen in the center. So H10. So this will be now C5H10O5. The technique is pentoses, 5 carbons. Automatically, the oxygen atoms will be also equal to carbon, 5 also. So 5 plus 5 is equal to 10, our atoms in the center of hydrogen. Now, this is the ribose, okay? Then we will put the molecular structural formula. So 5 carbons, okay? 1, 2, 3, 4, 5. Okay, like that. See, 5 carbons. Okay, and then again, double band oxygen. Okay, single band hydrogen. Okay, single band carbon to carbon, like this, like this. Single band, and the rest will be double band. Okay, oh no, sorry, single band. Oh my gosh. Okay, like this. So, okay. We can prove if we will be wrong in our molecular structural formula by counting each elemental component of individually the carbon atom, the hydrogen atom, the oxygen atom. Now, if the number of atoms in each element is not equal during our counting, that means our molecular structural formula is wrong. Okay, because the general formula is always correct. So there's something wrong with our molecular structural formula. Maybe we are wrong somewhere in the banding, the covalent banding, blah, blah, so on. So, or maybe our electrons in the outermost shell is not really correct, and that's why we are wrong. Okay, it's very important to match our analysis. Okay, like so it's easy to it's easy to justify. Okay, because we have the general formula, then it should be equal to the molecular structural formula as we go counting one by one the elemental component of the particular sugar. Okay, this is H OH. Okay. So always take note in the molecular structural formula, there's always a hydroxyl group. Okay. And then in the general formula, there's no hydroxyl group. It's always CHO, CHO, CHO. And it will matters only in the number of atoms each in the subscript. Okay. Subscript meaning down. Okay. So prescript up, subscript down, coefficient beside. Right? Okay. So HOH, my goodness, HOH. Okay, count now. So this is our covalent bonding. Again, covalent bonding. Why? Because all are being shared. The electrons in the outermost shell of each carbon atom are shared completely to hydrogen, oxygen, and hydroxyl group. Okay, count now. 5 carbon atoms. So 1, 2, 3, 4, 5. Hydrogen. One at the top. Okay. One at the bottom. So 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Correct. Oxygen, count that one. So at the top, 1. So the hydroxyl, 2, 3, 4, 5. This is correct. Okay, so meaning to say it matches as we count one by one the elemental component of this ribose, which is under ketosis. Okay. The number three example of aldoses is okay the glucose. The glucose we have in our bloodstream. Okay, in which the insulin hormone try to control that one. Okay, like that. Okay, so that you will not develop diabetes or type 2 diabetes. So the insulin hormone will control the adequate level of glucose in the bloodstream. So the one who will signal this one is the glucagon, okay, which is an enzyme, okay, an enzyme that catalyzes the reaction. He will signal to the insulin that we need more of this glucose in our bloodstream. So they are, partner with each other, friendship galore, or complementary with each other. The glucagon as an enzyme to catalyze the reaction, and the insulin hormone, okay, the regulation of glucose in our bloodstream. So they get the glucose in the glycogen. Okay, the glycogen is the storage of these polysaccharide sugars. Okay, that composed of so many glucoses there in the storage of polysaccharides house, so like a house. And this glycogen is full of glucose, and they will get there the glucose every time. Okay, and then this insulin and glucagon are, communicating with each other, something like a partnership, just like a business. Okay, like this. We do a business with each other in order for us. We have a good regulation of our glucose in the bloodstream. Okay, like that to avoid obesity, diabetes, okay, hypertension. Okay, like that. So this is number three example of simple sugar. This is the glucose. Okay. This is the formula of glucose inside our body. Even though we cannot see, at least we know that this is the structure of our glucose in our bloodstream. Okay, like that. We cannot just see, but in the laboratory test, they will get a sample, and it will behave like that, as they can see in the, like microscopic technology that has a lens to detect really in the computer. Okay, it will be shown there. Okay, new technology, something like that. The biochemical engineer and biochemists will do that. What we did now is only theoretical aspect and discussion of the basic concept. I cannot show you because we don't have laboratory here. If we have the laboratory, then I can also demo some of it through the procedure, okay, by using a procedure to detect those molecular structural formula by showing to you in a screen of a computer, okay? And I will also get sample, blah, 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 so on. So, okay, I will experiment also, but there's no laboratory here, molecular structural formula, and I cannot support that with laboratory test evidences. Okay? So number three is we have the glucose. Glucose is the hexoses. Oh my gosh! Di ba saya? Hexoses. Because of the word polygon, hexagon. The word derived there, the word hex. Hexagon, 6 sides of a polygon. The same here, hexoses, to 6 carbon atoms. It's just like that. Steel algebra will be used also in this topic, the basic algebra, okay? About polygon, the size, the numbering, blah, 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 so on. So, okay? So hexose is glucose. So 6 carbon atoms. So 6 atoms of carbon. So oxygen automatically is 6. I teach you, right? Oxygen 6. So 6 plus 6. Mainly, this glucose represents the reputation of a carbohydrates or a brand of the carbohydrate of all the sugars. When you speak about carbohydrates, this glucose represents always glucose the representative, but all are sugars. That's why when we speak about carbohydrates, the same formula with glucose: 6 atoms of carbon, 12 atoms of hydrogen, 6 atoms of oxygen, because this is the one who represents the reputation, the brand of a carbohydrates. Okay, it's not the sucrose, it's not also the fructose. Okay, like it, because those are derived from dehydration synthesis or polymerization reaction. Okay, like that. So glucose is the strongest one. Okay, C6 which are found in the storage house of our inside our physiological internal type. State like this formula because this represents really the general formula of carbohydrates, which is the glucose. Okay, representative. Okay, not the other sugars. Okay, very clear. Okay. So, C6 is, and now we draw the 6 atoms of carbon, 6 carbon. Okay, one, ganun lang siya. One, the important is you will understand. 1, 2, 3, okay, 4, 5, 6, okay. So this is now 24 hours until we die. These carbohydrates or glucose are stored in our body. Okay, without this we will die also. Okay, uh, because it gives us energy. Okay, if there's no glucose, then where is our energy? So we will become weak and eventually we will die. Okay, malo. So that's carbon, hydrogen. Okay, hydrogen. Wonder ko kung ano siya. Non-polar covalent band. Oh my gosh. I love it. Ganon. Really. Okay. Now, the glucose, there's a technique for glucose. Okay. Wait. Okay. You will only take the technique and the rest will be history. You will put that in your brain. Okay. And then it will be lasts forever. That is gonna be the mechanism regarding sugars, molecular structure formula. Okay, like that. Then you have to number that one from the bottom. For example, this one. So the bottom part will be carbon number 1. The second, going to up, carbon number 2, carbon number 3, carbon number 4, carbon number 5, and carbon number 6. So in the carbon number 4, it will be reversed there, the hydrogen bonding and the hydroxyl bonding. Instead of the hydroxyl group will be in the right side, it will now turn to the left side. Take note, okay? Like that. So it will now reverse. So this is the identification of the glucose. Okay? Like this. See, I reverse, right? This one. And the carbon atom number 4. See? This one. The carbon atom number 4 always take note. And the counting will start at the bottom, ha? And the top. Okay, like that. Something like that. Okay? Like this, and then, oh my gosh, the connection, double band of oxygen and H. Oh, see? It's almost like at the top, huh? Double band of oxygen and the C. Okay, like this. 6 atoms of carbon. So count 1 at the bottom, 6 atoms of carbon. Now we have 12 atoms of hydrogen. Count 1 at the top, okay, at the hydroxyl, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Instead of 1 and 1, it's 12, right? And then the oxygen, count at the top, 1 hydroxyl, 2, 3, 4, 5, 6. So the oxygen mainly attached to the hydroxyl group OH, which is an ion negative 1. Okay, OH negative 1. Something like that. Okay, H is positive 1. Okay, like that. Okay, so it's correct. Or else it will become wrong. Upon counting, it will not matches the C6H12O6. Now, there is number 4 examples of a simple sugar, okay, or monomers of sugar. We have the galactose. Okay, the galactose is the same with glucose. Have 6 atoms carbon, but the only difference is that the OH are reversed. The same with this glucose, but only in the carbon number 4. Okay, so I have the galactose. The same composition, okay, or the same components or elemental components, but or have different molecular structural formula regarding the orientation of its bond. That is called an isomer. Okay, the word iso meaning similar or same in English. Iso. Let's say we have term isotope, isomer, isosceles triangle, meaning equal sides of a triangle. Iso is being added there. So ISO. Isometric, meaning the same. Okay? So the word iso is always the same. Take note of that. Okay? The word iso. Isosceles, isometric, isotope. Okay? I'm just telling you if there's a word iso, so it's the same or similar. Okay? Like that. So, okay, what is an isomer? An isomer is an organic compound or any inorganic compound that have the same composition or elemental components but differ but or different molecular structural formula. Actually, I made my own definition because I understand. Okay, I was taking the books. If you want to memorize it. A bit is just the same for because I understand really, that's why I make my own definition like that. Okay, only the orientation are not the same. Molecular structure from H12O6 galactose and clear. Okay, but the orientation, oh my God, I will show you. My God, okay. So I will put, this is, galactose. Galactose. Okay. Galactose, if I'm not mistaken, that was 50 years ago when I taught this in engineering. Okay, and very long time ago. I think galactose is verified that also. Maybe I'm wrong. There's also another maltose, right? But I think maltose is more on the fermentation, this process. Okay, this galactose, I think this is from milk. Anybody correct me if I'm wrong or I'm right? Because I did not really specify that, the definition, word for word. Okay. That's only the purpose there. Okay. Okay. Then hydrogen bonding, okay, and OH bonding, and O bonding, okay, bonding, okay. Double bond of oxygen, okay, so hydrogen, okay, like this. It's just a game, but you have to understand. Like the galactose in the carbon number 4 and 5, an H attachment to the carbon atom, right? I told you a while ago. Okay, so that applies here. Okay, like that. Okay, it's gonna be like that. Okay, okay. So carbon number 4 now, reverse the H to the left. 4 carbon 4 carbon number. Carbon now. 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3. Hydrogen. 1, 2, 3, 4, 5, 6. So 2, 3, 4, 5, 6. So so this is the same in the general form in laboratory test, something like that. Okay. So doses. Aldose is composed of the ribose C3 and 6O3. Okay, now this is very high. Viceral formula, you consume the time. Okay, and you are not following the issue. So again, simple. Okay, I will tell you something. The first example of ketosis is an acetone family. So belong to another family. So that's the magic there, huh? For all our scientists before. Okay, especially the father of modern biochemistry, which is Carl Alexander Newton, May 30, 1956. Okay, really, experiment this thing, do a laboratory test analysis, and he proved something like that. Okay, and then we are wondering why was the acetone. Nakakatawa ka, di ba? Acetone is a ketone family, right? In organic chemistry, you can remember acetone, ketone family. Okay, something like that. Okay, so this is ketosis. Okay. That's why we have ketosis is a process of burning fats, the process or internal process of metabolism